Hello everybody, welcome back today. Today we're going to be doing a LeetCode hard question, which is binary tree maximum path sum. And here a path in a binary tree is denoted as basically a sequence of nodes where you have a path which is from some subtree's root, which is the left tree, and then plus the root and then the right tree. So essentially here, as you can see in this example, a path would be 2 to 1 to 3. Here, one path would be 9, negative 10, 20 to 7, and there's more paths there, but essentially it's the left tree plus the root plus the right subtree. And essentially it also tells us the path does not need to pass through the root, which is essentially pertaining to the actual whole tree. So it doesn't need to pass through this root, but it has to follow that order of a left, root, and right. And as soon as I say that, you guys can kind of think this is going to be some kind of DFS. So let's get into the iPad and figure this out. Alright, so let's get into the iPad explanation and let's figure this out. So basically I have that input from LeetCode here, and as you can see the output is 42. Now how is this happening, right? Well, like I said, our idea is going to be that the path essentially is defined by a left sum plus the root value, right? And then the right sum here. So root value plus right sum. This is the idea. Now, how does this work? How does this output make sense? Well, what we do is let's start at negative 10, which is the root, right? If we try to calculate a path sum for negative 10, or the maximum path sum if we started at negative 10 as our root, well, that would be the left sum, which is 9, right? And then we go to the right here and we check the maximum path sum, where in this case it would be 20 and 15, right? Because 20 plus 7 is 27, and then 20 plus 15 is 35, which is a bigger number. So the actual path here would look something like that. That's the path. So it's the left subtree sum, maximum sum, and then the right subtree maximum sum plus the root. That is your path. In this case, 9 plus negative 10 plus 20 plus 15 actually adds up to 34. However, we can get a more bigger sum. So essentially here, if after we're done with that 34 calculation, we know that's our maximum sum so far. So we can keep kind of like a variable here, max PS, which helps us track the maximum path sum. What we do is we go to the left. We'll check, hey, is my left path sum bigger if I start at 9 as my root, right? Well, if 9 is your root, there's no left tree and there's no right tree, so 9 is the only sum, and that's not bigger than 34, so we're not going to change it. Then we come to the right. Hey, let's consider 20 as my root for the path sum. Okay, let's go to the left, which is 15. We come back here, and then we go to the 7. Okay, we have 7, so 15 plus 20 plus 7 is actually 42, which is greater than 34. And as you can see, that is our maximum path sum because there's no more nodes to look at. So you can already see this being a DFS. Now, what kind of DFS? Well, before we actually find the path sum, we need to know the left and right path sums, right? So in order to do that, we need a postorder traversal. And it's postorder because post lets us go to left, then right, and then to the root, or any other calculations we want to make. So we get these two sums, and then we add it to the root and check with our maximum variable if it's bigger or not. Now, one more thing here is if we reach a null pointer, in this case, like here for 9, when we reach these ends, we just return a 0 because we're not going to add to the sum. And the way to calculate these left and right sums is basically we essentially go through all the nodes, right? We go through all the left tree nodes, right tree nodes, and as we go, we just keep adding up the values. So every time we make a recursive call, we just say, hey, let's go left, or let's add the current value, root value, and then go left or right, and then pick the maximum, right? That's what we want to do. We want to find the max path sum. So our recursive call is going to look something like, hey, root value plus the max of, we're going to call it to the left and the right, maximum of the two recursive values for the left and right subtree, and that will give us the max path to that point, right? And that's the whole point. That's how it's essentially like finding the height here. Now, you might be asking, what is the time complexity? Well, like I said, we're going to go through all the nodes. So as you can tell, it's going to be O of n, right? Space complexity is essentially just going to be, it's going to also be O of n, essentially because the recursive stack space, we're going to call at least O of n, or we're going to call at least n number of recursive calls because we're going through all the nodes. So this is going to be the time complexity. And as you can see, this hard might not be as difficult as it might be labeled as. So let's get into the code and let's figure this out. So let's get into the code here. So I'm using C++, but you can use any language the concepts do transfer over. So usually in tree questions, you want to create a helper function. It just helps you, separate the code, improves readability, and helps you debug, right? That's the whole point of a lot of programming and a lot of interviews. You want to write clean code. So first things first, our parameter is going to be a pointer to a node variable. Essentially at every recursive stack call, we need to know what node we're on so we can check the left and right and find the path sums accordingly. Then we pass a max path sum variable, and that is going to be passed by reference because we're changing that value in this function, because that is essentially the answer. This helper function is only helping us find a path sum. It's not helping us find the maximum. This is going to keep track of that maximum here. So here we have our base case here, which is going to be if the node is actually null pointer, meaning there's actually no value there, we're just going to return 0. And that's because this won't affect the path sum. We're not increasing, decreasing. It's just going to stay the same. Then we want to look into how we find the left path sum. That's going to be the maximum of 0, generate, and I'm just going to write this function, this call out, and then I'll explain it. So here what we're doing is we're saying we want to find the maximum of between 0 and the left path sum. This is going to help us find the left path sum. And why we're doing that is because a path is just a collection of nodes. While I did say it was left sum plus node value and then the right sum, if the left value is actually negative, there's no point in considering this because the path, again, is just defined as a sequence of nodes, right? It's not necessarily that you need to have something from the left side. If the left side is negative, maybe we just include the right side, which is positive, and that's our max path sum, right? Same thing with the right side too. If the right side is negative, we don't need to include it, right? If the left side is actually the positive value. So same concept here, but if they are both positive, then it's going to help us, it's going to contribute to the max path sum. And what we're doing in this function is basically we're going through every subtree and checking, hey, is that at this node, the max path sum between the left node and right actually the maximum? And that's what helps us find the answer for this case right here. And you might be thinking, hey, how is this generate function actually doing it? Well, remember, this is a post-order traversal. So we're going to actually add up after we go left, all the way right, because on the backtracking, we're going to add it up. So how we do that is we do the node value plus the max between the left sum and the right sum. And this is because we want the maximum path sum. We don't want a specific path sum. So we're just going to pick whichever one is maximum because that is going to guarantee to maximize our variables, right? And now you might be thinking, hey, what are we doing with this variable? So here, every time, we're just going to check, hey, is this one the maximum or is my left sum, right, plus root val plus the right sum, right? Is this, which one is more bigger? And which one is bigger is going to be our maximum path sum. And that's essentially the helper function. So all we need to do is declare that max path sum and make sure you don't actually declare this to 0 because the minimum path sum is not necessarily, it's not always going to be 0 because the values can actually be negative here, right? And that's why here you might be thinking that might mess up here, but it doesn't matter because the node values will make itself negative because when you keep adding negatives, the value actually becomes smaller, right? So we initialize it to minimum value here that the int can be. We call generate on the root, and then we pass this max path sum. And remember, we don't need to actually collect this max path sum because remember, this is just a specific path sum. This is not the maximum, right? So there's no need to get the value from the return here. So we just return the max path sum, and that will be the answer. So let's make sure we run this and have no compilation errors. And we do, and this should be node here. Just naming here, that's the problem. And as you see, yeah, we pass all these test cases. Let's go ahead and submit on LeetCode. Make sure we pass all the LeetCode test cases. As you can see, we did. And look, this was a hard question, but as you can see, if you break it down and think of DFS and the tree traversals, it's not that complicated. So yeah, make sure to leave a like. And if you guys want to see another question, there's another question that's related to this path sum, which is a medium. And so yeah, let me know in the comment section down below if you want to see this. But yeah, remember, like, subscribe, and I hope to see you in the next one.